Okay, so here's the next notes. Again, a lot of this is the same as what we've already covered. I just wanted to make sure that we got all the information that we needed. So please make sure that you go ahead and watch this whole video, because I will tell you that the problems are significantly more challenging in this video versus the other ones. Before we get started, the first part of this notes just talks a little bit more about why we do applications of systems and so forth. So let's just go ahead and jump right into our notes so we can get these knocked out as quick as possible. All right, so we're going to use applications of systems of linear equations when the application has two or more unknowns that may be necessary to use multiple variables. For example, today's bell ringer, we didn't know the price of sodas and we didn't know the price of pizzas. Two different things that we needed to know the price of, so we had to use two different variables. You can't use the same variable for two different items. Okay, we also, when two variables are present, the goal is to set up a system of two independent equations. Again, if you have two variables or two unknowns that you cannot solve, then you need to set up a system. Okay, we've been doing that. That's not anything new. To solve a system of equation, we use graphing, substitution, or elimination. Okay, we know those things as well. There are several types of application problems that can be solved using a system of linear equations and two variables. These are the different types of problems you're going to see. The cost applications, we saw that today with our bell ringer, the cost of pizza and the medium soda. This pizza and the soda. Mixture applications, we're going to do an example of that in just a minute. Mixture are a little more complicated than the other ones. You don't do a whole lot of those in Algebra 1, but there are a few that'll pop up here and there, and they are a little more tricky than the others. Applications involving principles and interest, again, that deals with money, and those are also tricky, and you do need to know those. Okay. Application involving distance, rate, and time, those aren't too terribly difficult. They also cross over into your classes such as IPC and physics later on, so those will come back. And then, of course, geometry applications, which we've already started doing that whenever you're dealing with any kind of shapes, like the rectangular buildings or gardens or stuff like that. We did one of those on your homework last night. All right, so the following here is just another example of steps on how to solve applications of system problems. These are good to add to your notes. Identify and label the two variables. Okay, and when you identify and label the variables, you need to tell me what those variables stand for. Determine the two linear equations detailed in the problem. So create two equations and then write them as a system. Generally, you do those two steps together. And then number 4 says solve the systems using one of the three methods: graphing, substitution, this should say elimination. And then finally circle a box your answer. This should come in the form of a point. Now, this isn't entirely true. It isn't always in the form of a point when you're dealing with application. In fact, most of the time it's not in the form of a point. So this is just when you're dealing with a regular type of system. All right, so let's just jump right into our first example. Okay, so it says at one store, 5 pairs of jeans and 2 sweatshirts cost $166, while 3 pairs of jeans and 4 sweatshirts cost $164. Find the cost of one sweatshirt. Okay, this is a great question, but let's just go step by step. It says, what are the two variables? Well, first of all, we don't know the cost. The first thing we identified is the cost of a sweatshirt. So the one thing we don't know is how much a sweatshirt costs. So we're going to identify that variable as S for, again, I'm identifying it, sweatshirt. Okay, the other thing that goes hand in hand with the sweatshirt, because usually the two items are similar, is jeans, another pair of clothing. We don't know what jeans are, so we're going to use the variable J for jeans. And again, identifying them is writing out what they are. Okay. Now, the next thing we're going to look at is what two linear equations can be derived from the scenario. Well, the cool thing here is that the equations are actually set up for you. if you read the problem closely, you'll see it says 5 pairs of jeans, and the word and means plus, 2 sweatshirts. Cost, the word cost means equals $166. So there's one equation. 5 pairs of jeans is 5J plus 2 sweatshirts, 2S, equals $166. Over here you have 3 pairs of jeans, and, which means plus, 4 sweatshirts, cost, again, is equals $164. So 3J plus 4S equals $164. Okay, the next step says to write 2 equations as a system of linear equations. Okay, well, we really already did that right here. So for this particular step, all I would really be doing is rewriting 5J plus 2S equals $166, and 3J plus 4S equals $164. And the reason they have that second step, or that step in there twice basically, is because some people will write this equation, then they'll write this one over here or something. They want you to line it up so that you see a system. Okay? And then finally, we're going to go ahead and solve. It's set up in standard form, AX plus BY equals C, AX plus BY equals C. They're both in that form. So we're going to use elimination in order to solve our system of equations. I'm going to keep those dollar signs to help us identify what the numbers actually represent. That's a good way to determine what the numbers represent. Hopefully, you'll be able to do that as you're working anyways without any issues. Okay, so if I'm looking at my system of equations, one thing I'm going to notice right away is that I cannot turn 5 into 3 or 3 into 5, but I can turn 2 into 4. If I multiply everything up here by 2, this will become 4. I don't want it to be a positive 4 because this is already positive, so I need to make this a negative 2 so that I can create a negative 4. So negative 2 times 5 is negative 10J. Negative 2 times positive 2 is negative 4S equals negative 2 times 106 is negative 332. Okay, because I picked the right thing to do here, I don't have to do any math up here. I'm just going to bring this down. So 3J plus 4S equals 164, and these are still dollar amounts. Okay. Now I'm just going to add the 2 lines together. Negative 10J plus 3 is negative 7J. Negative 4S plus S cancels, equals negative 332 plus 164 equals negative 168. To solve for J, I'm going to divide both sides by negative 7. This cancels, leaving me with J equals negative $168 divided by 7, negative 7, is going to give me $24. So each pair of jeans costs $24. Now, if I go all the way back to the beginning of my question, this is where highlighting is important, and going back to check to make sure you're doing the right thing, I'll find out that I'm not actually looking for the cost of jeans. I actually want to find the cost of one sweatshirt. So I need to go back. While I need this information to get my answer, I'm going to go back and find the cost of one sweatshirt. So I need to go back in and just pick one of my 2 equations, original equations right here. I'm going to pick 5J, and instead of J, I'm going to replace it with $24. So 5 times $24 plus 2S equals $166. And now I'm just going to solve that for S. Okay, so 5 times 24 is $120 plus 2S equals $166. Subtract $120 from both sides. This is going to eliminate, leaving me with 2S equals $46. Divide both sides by 2. That's going to let me know that S equals $23. So each sweater for one S or one sweater, it is $23. So that is the answer to our original question. Find the cost of one, I keep calling it a sweater, but a sweatshirt. All right, moving right along. If you need to, pause it to look over the word, but we're going to move right along. Okay, example 2. This one's pretty tricky. You got to be careful. I actually made a mistake the first time myself around. It says a pharmacist needs 8 ounces of a solution that is 50% saline. How many ounces of 60% saline solution and 20% saline solution must be mixed to obtain the mixture needed? Okay, so if X, it's already giving you X, X represents the number of ounces of 60% solution. It tells you Y. Y is the number of ounces of 20% solution. We want the amount of saline in the resulting solution. Okay, so I'm not really sure what these 2 blanks are for, but let's just go ahead and jump right into the problem. Well, the first thing is easy. I know I need X plus Y to equal 8 because the total ounces needed is 8, and X represents the number of ounces and Y represents the number of ounces. So ounces plus ounces should equal 8. Okay, now here's the catch. Okay, here's the harder of the 2 equations. I need to put a percentage because I've got to turn this into 50%. But this is 50% of 1. So what I need to do first is, well, let me just do it this way. I need to put my percentages with something in this equation so I can convert to 50%. Well, what I'm going to do is I'm going to put all my percentages where they go. So X belongs with 60%. So I'm going to put 60% X plus 20% Y equals, I can't just write 50% here because it is 50% at 8 ounces, not 50% at 1 ounce. It's 50% at 8 ounces. So I need to put times 8 here because I want 8 ounces. This can be tricky. I understand that. Okay? Now here's the other trick. This essentially is our system, but this is not mathematically valid. I do not use percents when I'm working in math. So I need to convert these percents to decimals. I'm going to go ahead and bring down my X plus Y equals 8. I need to convert this percent, 60% to a decimal. The way I do that is I move my percent sign 1, 2 places to the left, and I create a decimal instead of a percent sign. So this actually becomes 0.60x. Move my percent sign 1, 2. This becomes 0.20y. And then 80 times 50, or 80 times, this becomes 0.5. So 8 times 0.5 actually becomes 4. So now here's my system. X plus Y equals 8. 0.60x plus, I didn't put plus there, plus 0.20y equals 4. Now I can solve my system. Okay? Now the good thing about this system here is on the top, it's coefficient of 1, so I can turn this into anything. So I'm going to multiply the top by negative. Let me erase this so we can see it a little better. I'm going to multiply the top by negative 0.60. If I do that, I have negative 0.60 times x is negative 0.60x. Negative 0.60 times y is negative 0.60y. Negative 0.60 times 8 is negative 4.8. Then I didn't need, because I did the right variable and I did this right, I don't have to do anything with the second line. I'm just going to bring it down. And it's going to be 0.60x plus 0.20y equals 4. Now I'll go ahead and add these. Okay, negative 0.60 plus 0.60, those cancel. Negative 0.60 plus 0.20 is negative 0.40y equals negative 4.8 plus 4 is negative 0.8. Solve for y, divide both sides by negative 0.40. Divide this by negative 0.40. This cancels and I'll get y equals 2. So the number of 20% saline solution is going to be 2 ounces. I'm going to need 2 ounces of the 20% saline solution. Okay, now, of course, let's go back in. We need to find the 60% mix. So if I go back in and I solve it, all I'm going to do is do x plus y equals 8. Well, instead of y, I'm going to do x plus 2 equals 8. Subtract 2 from both sides. X equals 6. So the number of 60% solution should be 6 ounces. Okay, if we go back over here, the best method to solve, of course, we did that already, which was elimination. And our solution would be 2 ounces of 20% and 6 ounces of 60%. All right. If you need to pause it to take a look and make sure you get everything down, go ahead and pause it because we're going to go right into number 3. Okay? This is an investment one. It says Sonia invested a total of $12,000 into 2 accounts paying 7.5% and 6% simple interest. If her total return at the end of the year, the first year, was $840, how much did she invest in each account? Okay? So X is the amount in the account paying. You can make it 7.5%. The total amount invested was $12,000. Y is the amount in the account paying 6%. The total interest after 1 year, $840. Okay, so let's go ahead and work these out. Now, X is just an amount, okay? So if I'm looking at my total amount in each account, I would say X plus Y equals $12,000. Okay, that's pretty simple. Then what you're going to do is you will take the next one and say, okay, if the interest works out right, it should be, I got to put these percentages with there. Now, let's go ahead and convert the percentages first. When I convert a percentage with the decimal and a percent sign, I just move the decimal. So I'm going to move this decimal 2 places to your left. 1, 2. There's a decimal that goes right there now, and I put a 0 on that blank spot. So for my X, instead of X now, I'm going to put 0.075X plus, over here, I'm going to move it 1, 2. Again, I have a blank spot, put a 0 there. So it's going to be 0.06Y, and that investment should yield $840. Okay, so there's our system of equations. So let's go ahead and work that out. Again, the good thing with setting up the equation like this is you can turn this X or Y into anything. So I'm just going to go ahead and eliminate the X first. I'm going to multiply everything by negative 0.05 because I need to get rid of that 0.075 there. And it is negative, and a positive will cancel. So negative 0.075 times X is negative 0.075X. Negative 0.075 times Y is negative 0.075Y. 12,000 times negative 0.075 is negative 900. Didn't have to do anything to this one because I picked the right one, so I'm going to bring it down. I'm going to have 0.075X plus 0.06Y equals 840. Go ahead and add those together. Move this up for you. Negative 0.075 and 0.075 positive, those cancel out. Negative 0.075 plus 0.06 is going to equal negative 0.015y equals negative 900 minus 840 is equal to negative 60. I'm sorry, negative 900 plus 840 is equal to negative 60. To get y by itself, you divide both sides by negative 0.015. Divide this by negative 0.015. And you end up with y equaling $4,000. Okay, so the account paying 6% had $4,000 in it. Now, I know that these decimals are intimidating and they can be very intimidating, but please do not skip these problems when we do them on homework and we do them on worksheet. And please make every attempt to do these because these are going to show up on your STAR EOC exam. So please do not be afraid of these awkwardly three-place decimals and so forth, okay? Now to find out the amount that she had in the 6% account, we're going to go ahead. I'm going to move this over here. We're going to plug in that $4,000. That first equation is the easiest one. So instead of x plus y, I'm going to do x plus $4,000 equals $12,000. Subtract $4,000 from both sides. Okay, that's going to cancel. That's going to leave me with x equals $8,000. So she invested $8,000. Here's our answer. This is $8,000 in the 7.5% account, and she invested $4,000 in the 6% account. And that's all we need. Okay, if you need to pause it, pause it. We're moving right along. Let's look at example 4. This is a distance, rate, and time one. It says a plane flies 1,200 miles from Orlando to New York in 2 hours with a tailwind. The return flight against the same wind takes 2.5 hours. Find the speed of a plane in still air and the speed of the wind. So it gives you x and y. X is the speed of the plane. Y is the speed of the wind. Okay? It's giving you distance equals rate times time. So it's actually giving you a formula here. So the flight from Orlando is 1,200 equals x plus y, because let me explain this for you too, because this is kind of a complicated problem too. But again, it's another one that you'll have to see on the EOC. When you're flying with a tailwind, that means it is pushing your plane. You're going to fly faster. It's kind of like throwing a football or a frisbee with the wind. The ball is going to travel easier and faster and farther. Okay? When you're traveling with a headwind or you're going against the wind, it's going to slow you down. So in this case here, I'm going to take the speed of the plane. I'm going to add it to the speed of the wind. Okay? And I'm using my distance formula because distance equals RT. That's a regular distance formula you need to know. Okay? I'm going to use my distance formula and I'm going to figure it out. But I'm going to say, here's my speed of my plane plus the speed of the wind. That's going to create my rate. This right here. So here's my distance. This is my rate alone. And then this is my time. So distance equals rate times time. Okay, now if I work this out, if I distribute that 2, I'm going to end up with 1,200 equals, I can do reverse distribution, 2 times y and 2 times x, so 1,200 equals 2x plus 2y. Now here, I'm not going to add the tailwind because, or that speed of the wind, because I'm going against the wind. It is actually slowing me down, so I need to subtract the wind in this case. But again, this is my rate and this is my time. If I distribute reverse, and it took me 2.5 hours, that's the time. It took me a little bit longer because I'm going against the wind. If I reverse this, reverse distribution, I'm going to get 1200 because it's the same distance equals 2.5x minus 2.5y. Okay, so if I create my system, I'm going to have 1200 equals 2x plus 2y. 1200 equals 2.5x minus 2.5y. Okay, now here's my system. So let's go ahead and solve. Can I make 2 times 2.5? Can I make 2 into 2.5? Okay? Well, not very easily because I can't just multiply by 0.5 because that's half. That'll cut that in half. So don't get confused there. If I add 0.5, that would be fine, but not in a systems of equation. So can I make 2.5 here? No. So here's what I'm going to do. I'm going to multiply everything by the top by 2.5. Everything by the bottom by 2. Now, in this particular sense here, because I have a positive and a negative, I do not have to do a positive and a negative out here. I can do them both positive. And also, if this is throwing you off because the equal sign's over here and this number's over here, you can switch them around if you want. If you want to rewrite this as 2x plus 2y equals 1200 and 2.5x minus 2y, 2.5y equals 1200, that's fine. Okay? Well, let's go ahead and solve it the way we have it here. Okay, so 1200 times 2.5 is 3000 equals 2 times 2.5 is 5 x plus 5y. On here, 1200 times 2 equals 2400 equals 2 times 2.5 is 5x minus 2 times negative 2.5 is negative 5y. Okay, so now if we add these straight down, we have 3,000 plus 2,400 is 5,400 equals 5x plus 5x is 10x. 5y minus 5y cancels. Okay, I'm going to move this over because we're running out of room here. So now I have 5,400 equals 10x. To solve for x, I divide both sides by 10. Really what I do when I divide both sides by 10, that cancels. I'm just going to cross out one of the zeros, and that's going to be 540 divided by 1, which is 540 equals x. So the speed of my plane is 540. Okay, to find the speed of the tailwind, all I have to do is go back and plug it into one of my original equations right in here or up here, whichever one you want to look at. So what I'm going to do is I'm just going to take the top one because it doesn't have any decimals. I'm going to do 1200 equals, instead of x, now I'm going to do 2 times 540, okay, plus 2y. Well, 2 times 540 is 1080, so I have 1200 equals 1080 plus 2y. Subtract 1080 from both sides to solve for y. So 1200 minus 1080 is 120. 120 equals 2y. Divide both sides by 2. 120 divided by 2 is 60 equals y. So the speed of the wind is 60 miles per hour. So does it make sense? Is a plane traveling at 540 miles per hour makes sense? Yes. Speed traveling at 60 miles per hour, that's pretty fast for some wind, but if you're up that high up in the air, it's probable. I mean, it's definitely likely. Okay? So that's the answer there. So here's our answers. Okay, if you need to pause it because we're going to move right along into the last example. Again, I apologize that it is redundant and it's boring, but it is more difficult problems. Okay, the sum of two acute angles in a right triangle is 90 degrees. Okay, let's draw that picture real quick. Here's a triangle, and it's a right triangle. That means this angle right here is 90 degrees. Okay, well, a triangle equals only a total of 180 degrees. Okay, so that means this angle and this angle have to equal together 90 degrees. Now, an acute angle, just so you know, a definition is an angle that's less than 90 degrees. Okay, so it says